Science, a double-edged sword. It illuminates the world with knowledge, yet casts a shadow of potential destruction. It grants us the power to heal, yet also to harm. This duality is at the heart of our relationship with science, a force that can be both savior and destroyer. We marvel at its ability to cure diseases, connect us instantly across continents, and unlock the secrets of the universe. But we also grapple with its potential to create weapons of mass destruction, disrupt ecosystems, and manipulate life itself. The history of science is replete with examples of this paradox. The discovery of nuclear fission, for instance, led to both life-saving medical treatments and city-destroying bombs. The invention of the internet revolutionized communication and information sharing, but also opened doors to cybercrime and misinformation. These examples highlight the inherent tension within science, its capacity for both good and evil. This duality is not a flaw, but a reflection of the power that science wields. As we venture further into the uncharted territories of scientific exploration, this tension will only intensify. We stand on the cusp of breakthroughs in artificial intelligence, genetic engineering, and nanotechnology, each holding immense promise and peril. The question is not whether science is inherently good or bad. It is inherently both. The question is how we, as a species, choose to wield this formidable power. Will we use it to build a brighter future for all, or will we succumb to its destructive potential? The answer, ultimately, lies not in the laws of physics or the equations of chemistry, but in the choices we make. Let us first celebrate the extraordinary advancements made possible by science. In medicine, we have witnessed a revolution in our ability to treat and prevent diseases. Vaccines have eradicated smallpox and nearly wiped out polio, saving millions of lives. Antibiotics have tamed bacterial infections that once spelled certain death. Organ transplantation has given a second chance to those with failing organs. These breakthroughs are testaments to the power of science to alleviate suffering and extend human lifespans. Beyond medicine, science has transformed our world in countless ways. The invention of the printing press democratized knowledge and ignited the Renaissance. The development of electricity illuminated our homes, powered industries, and revolutionized communication. The creation of the internet connected us on a global scale, fostering collaboration, innovation, and cultural exchange. These technological leaps have not only improved our quality of life, but have also expanded the horizons of human potential, and we are far from reaching the limits of scientific progress. Researchers are working on developing new treatments for cancer, Alzheimer's, and other debilitating diseases. Engineers are pushing the boundaries of renewable energy, sustainable transportation, and space exploration. The pace of innovation shows no signs of slowing down, promising even more remarkable breakthroughs in the years to come. These advancements hold the potential to solve some of humanity's most pressing challenges, from climate change to poverty to disease. However, it is crucial to remember that these advancements are not without their caveats. The same scientific knowledge that can be used to cure diseases can also be used to create biological weapons. The technologies that connect us can also be used to surveil us. The tools that empower us can also be used to exploit us. This is the double-edged sword of science, and navigating its complexities requires both wisdom and vigilance. For every technological leap forward, there seems to be an accompanying shadow of unintended consequences. The Industrial Revolution, while ushering in an era of unprecedented productivity, also brought about widespread pollution and the exploitation of labor. The invention of the automobile, while granting us freedom of movement, also contributed to traffic congestion, air pollution, and climate change. The development of plastics, while offering convenience and versatility, has led to a global plastic waste crisis that threatens our oceans and ecosystems. These unintended consequences are not always immediately apparent. It often takes years, decades, or even generations for the full impact of a new technology to be felt. The invention of DDT, for example, was initially hailed as a miracle insecticide that would eradicate malaria and other insect-borne diseases. However, it was later discovered that DDT accumulated in the food chain, causing widespread environmental damage and harming wildlife populations. This delayed realization of DDT's harmful effects serves as a cautionary tale about the importance of long-term thinking and careful consideration of potential risks. The rapid pace of technological advancement in the 21st century further complicates this challenge. With each new breakthrough, we are essentially conducting a massive experiment on ourselves and our planet, often without fully understanding the potential consequences. Artificial intelligence, for example, promises to revolutionize countless industries, but it also raises concerns about job displacement, algorithmic bias, and the potential for misuse by malicious actors. Similarly, genetic engineering holds the potential to cure genetic diseases and enhance human capabilities, but it also raises ethical concerns about designer babies, genetic discrimination, and the unintended consequences of altering the human germline. The lesson here is not to shy away from scientific progress, but to approach it with a healthy dose of caution and foresight. We must acknowledge that every technological advancement comes with both benefits and risks, and that mitigating those risks requires careful planning, regulation, and ongoing monitoring. We must also be prepared to adapt and course-correct as needed, recognizing that the future is not predetermined but shaped by the choices we make today.